Good evening. Now we'll start with this AM90 to 6%, ADU 4020. Now, of course, you can find this ADU 4020 directly from the endowment table, but I want us to first do it in terms of whole life. So if I say ADU 4020, remember this is annuity. Okay, when it comes to annuity, we do not have term, we do not have pure endowment, we do not have endowment. We have only two. We have whole life and we have temporary annuity. So this is temporary annuity. Okay, so temporary annuity says that for a life aged 40, the payment will be given in advance for 20 years or death, whichever comes first. Okay, that is what our temporary annuity says. So it would be ADU 40, that means a whole life for a person age 40 minus if the person survives for 20 years. So if the person survives for 20 years, now the person is age 60, so we will remove, so therefore minus ADU 60, any annuity that was supposed to be given from age 60, we will be removing that. Okay, that is the logic behind the formulas. Let's so let's go to our 6%. 6% starts from something like 98 or something like that, or 102 actually, 102. So we have ADU 40. Okay, ADU value you can see here. We'll see ADU 40, ADU, this was 6%, yes, 6%, ADU 40. So ADU 40 is 15.491 minus V raised to 20, 20p40, we will see that later. First we'll see ADU 60. ADU 60 is 11.891 into, we'll say V raised to 20, V raised to 20, 1.06 raised to minus 20, and then 20p40. For 20p40 we'll have to go to L table. Here we are, L table, L60 by L40. So L60 is 9287.2164 by L40 is 9856.2863. So we'll get 11.9974. 11.9974. Okay, ADU 4020. Now, of course, we can see this directly in our endowment table. Okay, so here we are at 6% table. If we go down a little bit, we will find this endowment style table. Okay, endowment, and we have temporary annuity. In this, we have n is equals to 60. Okay, oh sorry, n plus x is equals to 60. That is what we are looking for. Age is 40 and 20. So you can see 11.998, right? 11.998. Okay. Solve the other two. I'll be back in just 1 minute. Okay, so I'm back, and then next A50. This is annuity in arrears. Okay, life annuity in arrears. We have always annuity due in our tables. So ADU 50 minus 1. This is what we'll be getting. And A bar 70 will just be ADU 70 minus half. Okay, this is exact, this is approximate, but this is the closest that we can get to. So our 6% table, okay, 6% table, ADU 50 will be here. So 14.044, that will just give me 13.044, and A bar 70, ADU 70 is here, 9.14 minus half, I will get 8.64. Okay, any problem here? Yesterday we calculated the temporary annuity for advance, right? That was the last thing that we did. Let's go for temporary annuity for arrears. Everything else remains same. The only difference is the payment is given in arrears. If it write the present value will say if the person dies within n years, then it is same as giving annuity in arrears. Okay, this is what we had when we were talking about whole life. Okay, annuity for kx years. And if the person dies after n years, okay, if the person dies after n years, then complete n years of annuity would already be given. You can imagine that if we were paying pension for 20 years, let's say from age 60 to age 80, if the person survives age 80, then all 20 payments have already been given to that person, right? So if the person dies after n years, then complete n years of annuity has been given. Okay. So we'll say this is nothing but present value is a minimum of kx comma n, right? Minimum of kx comma n. When we write our expected present value, we will say it is summation k going from 0 to n minus 1. We will have a k kpx qx plus k. This is the amount that we have already given to a person who survived k years and then died within the next year, plus we'll have an for anybody who survived for n years. So kpx. It's a complete n years of annuity given to a person who survived for n years. Then we talked about this, that we can also write this in terms of which payment is given to which person. Did we do that here?
Sir?
Yes.
Sir, why KPX, sir? When you survey total NS, we can write NPX, na?
Yes, NPX. My mistake there. Right? This is NPX.
Okay,
NPX.
sir.
Okay. So survive for n years, so NPX. Okay.
Sir?
Yes.
Sir, earlier in advance, we took for kx less than n, we took a kx plus 1, and here
Yes.
we took kx. Why
Yes.
is that so?
See, when we talk about annuity in advance, so we are talking about a person surviving for k years and then dying within the next year, right? So let's assume k is 5. Okay, so 1, 2, 3, 4 and 5. Let's say the person survived for 5 years and then died within the next year, that is this one. So if you're talking about annuity in advance, the payment should be 1, 2, 3, 4, 5 and then 6. This becomes nothing but payment at the beginning of the 6th year, right? So the year the person died, that payment was also given because the person died within this year, right? Any time in between. So the payment, because it was given at the beginning of the year, that is why that payment was given. Similar to a premium. Okay, premium is usually paid annually in advance. But if you're talking about a payment in arrears, like pension, let's say, we'll say the first payment will be here, second here, third here, fourth here, fifth here, and then we'll not be paying the sixth because the person died here. So we will not be paying the 6th year's premium, right? Or 6th year's pension or whatever. So now you can count, we have only 5 payments, right? So this is the number of years the person survived. That is exactly the number of years we paid them. So K, right? But when we talk about advance, we get one more than that. So therefore, K plus 1. Okay?
Okay, sir.
So when we talk about counting the payments, okay, I should have kept that. Anyways, I will make it here. We know we are going till n years only, but if I talk about x plus 1, x plus 2, x plus 3, and so on. The payment would be here, 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 and so on till time n. So the payment, we'll say first payment would be given to anybody who survives the first year. Second payment would be given to anybody who survives the second year. Third payment would be given to anybody who survives the third year. If we are counting according to payment, we'll say summation K going from 1 to n, because we will be giving maximum of n years of payment, right? For, we'll say V raised to K, KPX. Payment at time K would be given to anybody who survives K years. Okay. Both of these we'll say is nothing but A, X, N. This is also A, X, N. Okay. So you have to be very careful while writing any of these formulas. You can see here K and here K. They are not the same case. Why? Because this K means the number of years a person survives. So that will go always from 0 to whatever value you want to take it to. So if I'm talking about n years of term, it will always go to n minus 1, because after n years we will stop that policy. Okay. So whatever is happening, that is happening before n years only. So if the person survives n years, then we are not concerned about what happens next. When the person dies, we are not concerned about it. So when we are talking about death of the person, we are only worried about the person surviving till n minus 1 years and dying within the next year. That is why we are going till n minus 1. And if the person survives, then this, after that we are not taking anything into consideration. So we don't know when the person might die after this, and we don't care about it, right? Because our policies are ended. But here K is nothing but the time of payment. Which payment is given when? So therefore, first payment given at time K, okay, or given at time 1 to anybody who survives that time. So therefore this K is important for us. Okay, so this is time, this is not number of years of survival. Okay, so again, two ways of writing. Now if you remember, K going from 0 to n minus 1 was A due x n. That means we are going from our first value. If first value, because we'll say V raised to 0 is 1, and here 0 px, everybody survives times 0, so therefore 1. Then plus, we are going to have discounting for anybody who survives the first year. Okay, 1 year of discounting. Second year discounting for anybody who survived for second year. Okay, and so on. Last would be V raised to n minus 1 px. Okay. Whereas when I am talking about summation K going from 1 to n, V raised to K, kpx, we are talking about annuity in arrears, ax n. This would be going from v px plus v square to px and so on. The last would be v raised to n npx, because the payments are at the end of the year. This is also n years of payment. This is also n years of payment, but you can see they are different. So we don't make direct relation between these two. But if you want to make the closest relation that you want to make, we'll say it is a due x n will be equal to 1 plus a x n minus 1, because I can say this is nothing but going till n minus 1 years in arrears. This is same as going till n minus 1 years in arrears. So you can make this relationship. So remember, a due, or if we write ax n, this will not be equal to a due x n minus 1. Okay, this will not be equal to this. So this is a relationship that might be useful. You should remember this. Okay. And you should avoid this kind of mistakes. But we know our ax is actually equal to a due x minus 1. Okay, that is always true. Okay, don't relate this to this. Okay. So this was our expected present value. What about variance? Variance of present value we'll say is equal to variance of, this is what our present value was, minimum of kx comma n one minus v raised to minimum of kx comma n upon I. Now remember yesterday what we did? We said minimum of kx, not minimum, just v raised to minimum of kx plus 1 comma n was n year endowment. Okay, this was nothing but present value for n year endowment. That is what we use to find the variance. But here we have kx, we do not have kx plus 1. To make it into kx plus 1, we will be multiplying and dividing by v. So I'll say variance of v minus v raised to, we'll have minimum of kx plus 1 comma, I will have now n plus 1 upon, this will become d. So take d out, v is removed. I will have 1 by d square, variance of v raised to minimum of kx plus 1 comma n plus 1. So this would be present value of n plus 1 year endowment. This is present value of n plus 1 year endowment. So this would be 1 by d square 2ax n plus 1 minus ax n plus 1 whole square. Okay. So variance of temporary annuity in advance and arrears are not same. For whole life, yes, they were same, but for advance, for temporary, they are not same. We talk about continuous. Okay, when we talk about continuous, what we will say? We'll say that present value will be equal to A bar Tx, annuity given till person immediately dies, and will stop that annuity when Tx is less than n, and annuity would be given, already be given, everything would be given if Tx is greater or equal to n. So present value we'll say is minimum, we'll say A bar minimum of Tx comma n. So our expected present value, we'll say integration going from 0 to n A bar t tpx mu x plus t dt. Okay. So if a person anywhere in between 0 to n dies, survives till time t and dies within, immediately, mu x plus t is dies immediately at age x plus t, then this much payment would have been already given. Okay. Plus A bar n would have been given to anybody who survives NPX. And we can definitely make the other equation. We'll go 0 to n. Payment at time t would be given to anybody who survives time t dt. This is also A bar xn. This is also A bar xn. Now just in chapter 16 we studied capital A, that was our assurances. In chapter 17 we are studying small a, that is our life annuities, and you will get confused many times, because when I was studying, even when I started teaching, many times I used to write capital A instead of small a instead of capital A. Okay, that will be a problem now, because I've been teaching for so many years, almost it has been 4 years for me teaching the subject. So now I'm I don't get that much confused. Sometimes yes, I make mistakes, but not that much. So it will take time. I'm not saying that it will require 4 years for you to get grasp of this, but it will take some time, maybe till chapter 20 or something, then you will be perfectly getting grasp on capital A and small a. Okay, till then you will make small mistakes, don't worry about it. Okay, just try to learn from it and try not to make it again, right? What about variance? Variance of present value, so variance of A bar minimum of Tx comma n. V raised to minimum of Tx comma n. So this is 1 by delta square variance of v raised to minimum of Tx comma n. This is present value of n year endowment. The only difference is this would be payable immediately on death. So therefore variance will become 1 by delta square 2a bar xn minus a bar xn whole square. Let's talk about how would we find these relationships. Okay, so we know that a due xn can be written as a due x minus v raised to n npx a due x plus n, right? Now we can use the same logic for arrears as well as continuous. So we'll say axn would be ax minus v raised to n npx ax plus n. Same way a bar xn would be a bar x minus v raised to n npx a bar x plus n. Okay. Now we know the conversion between arrears and advance as well as continuous and advance. We will do that to figure these values out, right? Let's say using AM92 4%. Find let's find these two values. We'll first write it in terms of a 3510 will be equal to a 35 minus v raised to 10 10p 35 a due after 10 years sorry not due a after 10 years the person becomes 45, so let's say a 45. Now this we know the relationship, right? Ax is nothing but a due x minus 1. Okay, so this table was of 6%, we said 4%, so let's go to the 4% table. This is our 4% table, 35 and 45. We have values here 35 and 45. Okay, I don't need to write in terms of a due because we know it is just a due minus 1, so I can just subtract 1. That will not be a big problem here, right? So a due 35 is 21.003, so it will be 20.003 minus, I will write 45, I'll get 17.823 into 1.04 raised to minus of 10 years and then multiplied by, I will go for L. 35 and 45. 45 9801.3123 on 9894.4299. So 8.0757. What about A bar? We'll say A bar 35 will be A bar 30 minus V raised to 5, 5p 30, and then I'll have A bar 35. Again, while writing formula, I'll keep it like this. We know the relationship. We know A bar 30 will be A due 30 minus half. I will directly do it in the calculator. So I'll go to again 4%. Table, A due 30 is 21.834. Okay, 21.334. Okay, subtracted 0.5 from it, minus I would need A due 35. It is 21.000003, right? 21.003 would be 20.503 multiplied by 1.04 raised to minus 5 multiplied by, let's go to L. So 35, that is 9894.4299. 30 would be 9925.2094. Any problem here?
Sir, what does that mean, sir? That means the person aged 35 has to pay 8 rupees for 10 years.
No. It is the present value of the annuity. Okay, so now see, usually when we were talking about say 10 years of annuity, so usually we used to say that the payment will be 10 payments exactly, and we used to say the only thing that is reducing the value is the discounting factor, right? The rate of interest or discounting factor. But now what happens is there is another factor, that is if the person stays alive. So there is no guarantee that all 10 payments would be given. A person who dies early will get less number of values, okay, less number of payments. So accordingly they have calculated what is the expected value, that expected present value. So not only the expected value of payments, but also the present value is taken of those values. So we are getting that the expected present value would be 8.07. So it might be due to less number of payments, or it might be due to present value as well. So you can easily calculate how much would be the present value of 10, right? We can easily calculate this, right? So you can see how much is the effect of the mortality in it. So this value tells us the expected present value. Now see, why are we calculating expected present value? Again, because individual, this number would be for an individual who is taking policy, this number will be useless. Okay, because we cannot predict when a person might die. Okay, so there is no way for us to predict that. Okay, so what we are doing here is, for an insurance company, because a lot of people are buying the same insurance, we'll say among those masses we can predict what might happen, how many percentage of people might die within those masses. So at what age, how many people might die, that is what we were doing with life tables, right? We are using now those life tables to figure out how much would it cost us. So if I sell you if I sell a 35-year-old person an annuity in arrears going for 10 years, so if the person will get 1 rupee every year at the end of every year, if the person survives, right? So it will cost me 8.07 per policy that I sell. So let's say I'm talking about zero profit, zero loss. I'm assuming this is exactly what would happen. So what I will do is, this is the cost of that policy that I will keep. This is the cost of policy that I will keep. Okay. So to buy a 10-year of annuity, this is the amount a 35-year-old would pay. So we are actually calculating how much would it cost to the company. Okay. Any other doubts?
Sir,
Yes.
you are saying that for 10 rupees, actually each 1 rupee per year, this is the present value. The company will.
This is not present value. Again, this is
expected
present value. Yes. So this would be the 10-year present value, right? We know exactly 10 amount would be given, right? 10 payments would be given. Here, we may not be, will not be giving everybody 10 payments, because some people might die early. Okay, so this is the cost of doing that kind of a or making that kind of a policy. Okay. So basically what we are doing here is trying to figure out that if we are investing the money at 4% rate of interest, okay, and we will be giving certain number of people certain amount at certain dates. Okay, we don't know which people, but we know how many number of people would be collecting how much amount at what dates. So we are trying to figure out how much should we ask them, how much should we charge them, so that we will be able to fulfill our contracts. Okay. Now, of course, we'll be using this in case of premium. That means how much money will we get. We'll be using this in case of pensions and stuff, how much money we will have to give. There are other annuity style, payments as well. Like again, if let's say today I win a big lottery, rather than, saying that I keep all the money, because I might not be financially very good with money, I might spend it all. I would give it to some company and say that pay me this much amount every single year. Okay, so that I can make sure it stays for a long time. Okay, so I can make such kind of an annuity for myself.
Sir, that yes. 1 rupee for each year, whether company is paying or the policyholder is paying to the company, sir.
See, if it is something like premium, person is paying to the company. Okay, if it is something like a pension or an annuity that the annuity contract will be studying, okay, then the company would be paying for the person. For mathematics, it does not matter, right?
For,
Mathematics will be same.
for this case, sir.
Hmm?
For this
Again,
case,
again, I have not written anything, right? So it can be premium, it can be pension, I don't know. A 35-year-old might take an annuity, right? Or maybe I am giving them a term assurance for which I am asking them to pay the premium this much. Premium is usually paid in advance, right? 99.99% cases, the premium will be charged in advance. Will not be waiting for 1 year of contract to be over before we ask them to for the premium payment, right? So usually the arrears are usually not premiums, because premiums are usually paid in advance. Okay.
so, I will tell sir whether first tell me whether I am right or wrong, sir. So the company charges 8 rupees for the person, and it gives annuity of 1 rupee each year for 10 years to that person. Am I right, sir?
Yes.
For this case.
Yes. So in this case, that is what we will be saying, that company is charging 8.07 for this style of contract. Okay. So the contract is the company would pay 1 rupee each year at the end of the each year for 10 years or until death. Okay. So whichever comes earlier.
Thank you, sir.
Okay. Okay. Now, see, throughout this chapter 16 and chapter 17, we are also studying chapter 18 together. Okay, so don't get confused if you don't find stuff or I just jump to chapter 19 later on. Okay, because chapter 18 is all about these relationships that we are actually building together. Okay, so these are all things given in the chapter 18. Okay. Of course, we may have deferred annuity, it might be in advance deferred annuity. We'll write it as n/a due x, right? So that is just after n years, the annuity in advance will start for person age x today. The person is age x. Okay, so we can write it in two ways. One is same as what we write in assurance. We can say v raised to n npx. That means discounting for n years, and if the person survives for n years, then the annuity starts a due for a person who is now age x plus n, right? For a person who is age x plus n. There is another way of writing this. We can say, let's start an annuity from age x and just not give them the annuity for first n years, right? Subtract the temporary annuity for n years. Okay. Now this is exactly what we used to also write when we were taking our level annuities. Okay. So in case of level annuities also, if I say n deferred a due x, or a due m deferred a due n, that would be what? That would be v raised to m a due n, right? Or this can also be written as a due going for m plus n years and just subtracting the first m years of annuity, right? Okay. subtracting the first m years of annuity from the total. So similarly, we are making a deferred annuity here. Any problem? Now this we can write it in terms of arrears as well as continuous also. So if I say arrears, n deferred ax will be v raised to n, npx ax plus n, that will be again ax minus ax n. Same thing continues. Now this is again the concept how we are finding our temporary annuity formulas, right? Temporary annuity formulas, now you can rearrange and you will get the answer. It is just whole life minus deferred. Okay. Now from here you can say that we are starting chapter 18. So as I said, we have done a lot of things before that will be introduced in chapter 18, but we'll do a few. I think the name of chapter 18 is something like evolution of assurances and annuity. So what we'll be doing in chapter 18 is that we are going to see how annuities and assurances can be related to each other. Okay. Now see, A due x we said was nothing but expected value of the present value. The present value of A due x was A due kx plus 1, right? This is what we had. We can write this as expected value of 1 minus b raised to kx plus 1 upon d. We can take d out, expected value. When we take d, something that is multiplied, when we take out, it remains same, 1 by d, expected value of 1 minus v raised to kx plus 1. And then from that 1 by d, if I take this 1 out, expected value again will of a constant will be the same. So I'll have 1 minus expected value of v raised to kx plus 1. Okay. And this is nothing but present value of whole life assurance, right? So present value of whole life assurance, we are taking expected value of that. So expected value will just be capital A. This gives me 1 by d, 1 minus capital AX. So we can relate them, A due x and capital AX. Rather we write capital AX must be 1 minus d times A due x. Okay, 1 minus d times a du x. We can do similar thing with a bar x. Expected value, we will have a bar tx. We will get expected value of 1 minus b raised to tx by delta. That will just give me 1 by delta into 1 minus expected value of v raised to tx. V raised to tx is just present value of whole life assurance for payment immediately on death. Okay, and that just gives me 1 by delta 1 minus a bar x. So again, if you rearrange, you will get a bar x will be equal to 1 minus delta times a bar x. Important formulas, we do use them, so definitely make sure that you remember them, or at least write them for now, right? Similarly, if I solve for other stuff, I will get axn, that is our endowment value, will be 1 minus d times a du xn. Okay. And a bar xn 1 minus delta times a bar xn. Okay. Next, we'll talk about annuity payable m times a year. Now, when we were studying a normal annuity, level annuity, we took it as p times a year. Here, we will not be using p because p we use for a lot of different things. Mainly, p is used for, capital P is used for premium, and small p is used for probability. So we will not use p for general terms. That is why we have used m here. Now when we say annuity is payable m times a year, what we are doing is we are finding now the expected present value of, or let's write. Okay, so we are finding expected present value of an annuity of rupees 1, okay, rupees 1 per annum, payable m times each year. Okay, payable m times each year into a life aged x, right? So when we say payment of rupees 1 per annum, payable m times a year, each year, okay, so you can say payment each year is going to be 1 by m per or sorry, payment each time, I'll say payment each time is going to be 1 by m. Every whatever 1 by mth time period, each time the payment is going to be of 1 by m. Okay. Now here the complication becomes, because the mortality that we have been calculating, those mortalities are always per annum basis, right? Our table are of per annum basis. Now here, if we want to figure out whether, let's say monthly payment, whether the payment of January should be given, that depends on the mortality rate, okay, whether the person is alive or whether the person is dead. Similarly, whether the payment of February would be given. So that all of these, we will need that monthly mortality to figure that out. Now again, when we are talking about what would happen in future, we talked about this when we were studying chapter 15, that it is not when we squeeze our time period into 1 month or maybe half year or maybe 1 day, it will not be very accurate, just because there were 5 people of a certain age that died in 2019 January, let's say 15th, does not mean in 2022 also exactly 5 people will die of the same age on January 15 January 2022, right? So from past we cannot predict exactly what would happen in the future, right? So if we want to figure out that what would happen, what might happen in the future, we will always be taking a broad range, and we figured out that broad range, 1 year broad range, is a good range to calculate our values accordingly. Okay, so if we squeeze that time frame, into smaller time, time periods or whatever, the probability starts becoming less and less accurate. Okay, so yes, we can calculate very easily each day how many people die. So we can make those mortality tables according to per day. But then the accuracy starts becoming smaller and smaller. Okay. So that is why all the tables are made according to per annum basis. That is why all the calculations are done in terms of per annum basis. But if we are trying to figure out whether this payment would be given or not, each monthly or each quarterly, the premium can be payable monthly, premium can be payable quarterly, half yearly. There are many options that you get, usually these 4, right? You get annual or half yearly, quarterly or monthly. These are the possible premiums. And if the person dies, let's say in June, then July to December premium would not be paid, correct? So therefore, for us as a company, we should know very accurately how many number of premiums we might get. Of course, we cannot know accurately, so here we will use some kind of approximation. First, let's talk about how we will write it. So let's say if I'm talking about advance, okay, in advance I will write it as A due X payable M times, okay, A due X payable M times, and that we will write it as summation. Okay, now here instead of K I will be writing as T, that is the time that we are talking about. Okay, so first of all, okay, first let me write it properly. A due X payable M times. So we'll say a payment of 1 by M is given each time. Each time at the beginning it will be 1, then the next payment, the second payment would be V raised to 1 by M, right? And this would be given by a person who is still alive at that time. So 1 by M P X. Similarly, plus we will have V raised to 2 by M Px, and so on. This goes on forever. This is how we will do our calculations. Okay. So we'll say the time of the payment and the person who is alive at that time, that is the payment that would be given. Right. So basically I can say this is 1 by m summation of t going from 0 to infinity will have v raised to t by m px. This is how we will be writing our formula. As I said, this probability is very difficult for us to calculate properly. So what we will be doing is we will be taking an approximation. Now there can be many ways of approximating these values, but we will take a specific one. Okay, we will say, okay, approximately a due x payable m times can be written as a due x minus m minus 1 upon 2m. How do we get it? Why do we get it? Is not part of our course. Don't worry about it. This is the approximation that we get. Okay. Similarly for arrears, okay, for arrears we will say that our ax payable m times will be 1 by m summation t going from 1 to infinity. We will have v raised to t by m px. Okay. And then we say ax payable m times should be equal to, we get our ax plus m minus 1 by 2m, or you can write this in terms of a due x as well. You will get a due x minus m plus 1 by 2m. Just remember one of these. Even today I get always confused because I tried to remember both of them when I was learning it, and even today I get confused because of it. Just take one of them. Okay, either write in terms of ax or write in terms of a due x. You can always convert from one to the other, right? You can always convert one to the other. Okay. Of course, when we are talking about payable m times a year, we will not be getting continuous because we cannot pay m times a year. Now similarly, if I want temporary, if I say a due xn payable m times a year, always write it. Again, our basic formula of temporary annuity. Okay, so I would get a due x minus v raised to n npx a due x plus n. All I have to do is make both the annuities payable m times. Payable m times, payable m times. Similarly, ax payable m times, same thing, ax minus v raised to n npx ax plus n. All I have to do is make it payable m times, payable m times. So a lot of formulas are very easy to remember because they follow the same pattern that we have seen before. Okay. So we see a lot of patterns that we have seen before. Now if you solve this and rearrange in terms of your a due value, this will actually give you a due xn minus m minus 1 by 2m, okay, and 1 minus of v raised to n npx. Okay. let me write it properly so that m minus 1 by 2m 1 minus v raised to n px. Again, if I write this in terms of a du x n, this would be minus m plus 1 by 2m 1 minus v raised to n px. Let's find a du 50 15 payable 4 times. Okay, I will do it with this as well as by this. I will show you both the methods. First with this method, so we'll say this is equals to a du 50 payable 4 times minus v raised to 15 15p 50, then we'll have a du 65 payable 4 times. Now we'll separately calculate a du 50 payable 4 times should be a du 50 minus m minus 1. M minus 1 would be 3 by 2m. 2m would be 8. Okay, so this is what we had, right? A du x minus m minus 1 2m. This gives us, okay, let's take this for AM92 4%. Let's write AM92 4%. AM92 4%. We want a du 50. A du 50 was 17.444. 17.444 minus 3 by 8. So you have 17.069. Same thing we'll do with 65. We'll have a du 65 minus 3 by 8. For 65, we have 12.276 minus 3 by 8, 11.901. Now we'll require v raised to 15, 15p 50 as well. V raised to 15, 15p 50. I'll calculate it separately because we'll require that for the second method as well. 15p 50. So you're talking about 4%, so 1.04 raised to minus 15. For P, we will go to again our L table. Here we have our L table. L65. On L50. we'll put in our formula. If 17.069 minus 0.504334 into 11.901. So this becomes 11.0669. Okay. Now, as I said, we had another way as well. Now we had this way only because our addition of x and n becomes 65, and we know we have tables for 60 and 65 as well, right? Addition becomes 65 here. So we could have written this A due 50 15 payable 4 times as A due 50 15 minus m minus 1, that is 3, upon 2m, that is 8, into 1 minus v raised to 15 15p 50. So we have already calculated this. Let's see this 4% table. So these endowment style table, right? Here we want 50 15. So age 50, we'll look for age 50. 50 15, we have 11.253. 11.253. minus 3 by 8 multiplied by bracket 1 minus of v raised to 15 15p 50, that is 0.504334. You can see that we will have nearly the same value. 11.0671. Of course, there is a difference. The only reason is because of the number of decimal points they have taken in tables. Don't worry, both of these will be acceptable. Any problem? Let us write a small question. Okay, let's say for mu x is equals to 0.008. This becomes nothing but constant force of mortality. We are saying the force of mortality is 0.008. Okay. For we'll say where x can be anywhere between 50 and above. Okay, let's say delta, we are talking about 4%, and we'll calculate a bar 50 as well as our a 50. Okay, a bar 50 and a 50. Remember, when we had constant force of mortality, we could do our integration. If we did not have constant force of mortality, integration becomes very difficult. First of all, what is our integration? A bar 50 would be integration anywhere from 0 to infinity v raised to t tp 50 mu 50 plus t dt. This is our formula. So first of all, we know v raised to t. V raised to t, we can write it in terms of delta. We know mu that is given to us. Let's find Tp50. Now for constant force of mortality, you can directly write it as e raised to minus mu t. Okay, we know that it is Tpx is actually e raised to minus integration going from 0 to t mu x plus s ds. This is the actual formula. But if we have a constant force of mortality, our integration gives us Tpx is equals to e raised to minus mu t. So in terms of constant force of mortality, you can write this. Okay. So because we have a constant force of mortality here, I can write this as integration 0 to infinity. I have e raised to minus delta t and e raised to minus mu t, then mu dt. Mu is just a constant, will come out. I will have integration 0 to infinity e raised to minus mu plus delta t dt. Integrated, I will have e raised to minus mu plus delta t upon minus mu plus delta 0 to infinity. When I put infinity, that will give me just 0. E raised to minus infinity is 0. When I put 0, e raised to 0 is just 1. Okay. So I'll get this as nothing but mu upon mu plus delta. Without even knowing the values of mu and delta, this is the value that we will get. Okay. And this 50 did not make any difference. It could have been any number. Just because the force of mortality is constant. So we know mu is 0.008 upon, I'll have 0.048, 0.16667. We know what our TPX is, right? We know we can easily calculate what our TQX is going to be. It's just going to be 1 minus of this. So when we are finding our A50, that is payable at the end of the year of death, we'll say it is, okay, according to formula, what happens is it is summation k going from 0 to infinity. We will have v raised to k plus 1, kpx q x plus k, or in here I can write 50 and 50 plus k. So that gives me, first when I put k is equals to 0, I'll get v q50 plus v square p50 q q51, then plus v cube 2p50 q52, and this goes on forever. This goes on forever. So accordingly, we can easily know what our TP50 to P50 is going to be. We know our TP50 is e raised to minus mu t. That we know. We know what V is, e raised to minus delta. Right. What about Q? Okay. So Qx or Q50 plus K, let's say Q50 plus K can be written as 1P, or I'll say 1 minus 1P 50 plus K. And we know this does not matter when we are talking about force of mortality, right? T is 1, I can substitute it here, and I'll get this as 1 minus e raised to minus mu. This will be true for all case. 0 to infinity, because we have constant force of mortality. So when I substitute that, I will get A50 as V is e raised to minus delta. Q50 would be this. I can take this out, right? For each one of them, I can take it out. It will be better. 1 minus e raised to minus mu outside. And then we'll have e raised to minus delta plus e raised to minus 2 delta and P50, just put t is equals to 1. So e raised to minus mu. And plus second, we'll have e raised to minus 3 delta and e raised to minus 2 mu. And this goes on forever. Again, I can take e raised to minus delta out. And the rest is nothing but geometric progression, right? Geometric progression. Infinite GP should give me 1 upon 1 minus e raised to minus, we'll get delta plus mu. This is our formula. Now we can substitute. Okay, here we got 0.16667. Let's see what we get here. Minus delta, that is 0.04 into 1 minus e raised to minus mu 0.008, 1 minus e raised to minus delta plus mu, that would be 0.048. So we have 0.163351. You can see they are nearly same. What might be the difference? We know our a bar x is approximately 1 plus I raised to 0.5 ax. We have delta in terms of, we have rate of interest in terms of delta. So if I write this approximately, okay, this would be e raised to minus 0.5 times delta ax. Let's find what this is. Actually not minus, plus, e raised to plus. So if I multiply this with e raised to 0.5 into 0.04, you'll see we'll get nearly the same value, right? We should get nearly the same value. This is why we use such approximations. They are nearly the same value. But of course, we have used other approximations here. We have assumed constant force of mortality. In real life, that is never going to happen, right? As the age increases, the mortality should also increase. So mortality is dependent on age. But as we talked about this before, these kind of calculation, the mathematics that we have cannot just calculate, or integration or geometric progression will not be able to take force of mortality that is increasing with time. It will be difficult to make equations for that. Okay. So our aim here is to understand how things work in terms of insurance, okay, and know the basics, know the concept behind it, okay. And then if need be, you can use computers, you can use Excel, you can use many different methods to solve complex mathematics, okay. So solving complex mathematics is not our aim. Our aim is to understand how things work in insurance industry so that we can apply our knowledge. So the concept of this is important. How we can convert this when we have a force of mortality, that is important. So therefore, how did we get this is very important. The concept of this is very important. Okay. And then how we convert this into this is very important. Why we take constant force of mortality, that is important. In real life, it will not be constant. That is important.
Sir,
Yes.
can you explain A50 one more time, sir?
This is just a formula, right? What we are doing is we are substituting value of K. When we substitute K is equal to 0, we'll get V. 0 P50, 0 P50 is just 1 and Q50. So here we put K is equals to 1. So V raised to 2, 1 P50, Q51. Put K is equals to 3, K is equals to 2 and so on, right? So substitution. Then we know when mu is constant, Tpx is mu e raised to minus mu t. That is what we have written here. Then this is because 1 year Q, as we said, when mu is constant, age really does not matter. So therefore 50 plus K does not make much difference. 1 minus 1 P this. That we'll write it this. Just put T is equals to 1. Then it's all about substitution. This we have taken common because for each one of them it's the same. Taken common, and then this becomes infinite GP. Okay. So again, this is an approximate way of calculation, but of course this is all they would give us in our examination. Okay, they would not be asking us any very complicated style of questions here. Okay. So now we have learned a lot of relationships, a lot of formulas in chapters 16, 17 and 18, right? So in terms of assurance, in terms of annuity, and how we can convert one into the other. All of them are going to be very important, especially the expected present value. We will be using the variances sometimes, but not always. Okay, but the expected present value will be using always from this point on till chapter 28. All this capital A and small a we will be using every single time. Okay. So concepts are important. That is the summation formulas, the present value understanding and stuff. The derivations not so much. Don't think about the derivations as derivations. Think about it as logic, why we are doing it. So that if in the future I ask you how to make something out of assurances and annuities, you should know the logic behind it. Okay. So if I give you a complex formula and ask you to prove that this is equal to this, you should know the logic behind everything. So it's not about derivations at any point in all of these 13 papers. It's about the understanding. Okay. If your understanding is good, if you know what kind of functions or what kind of formulas we can use to derive something, then you don't need to understand, you don't need to remember the derivations. Okay. So lot of formulas. I would want you to keep updating your formula sheet every single day. Keep solving small sums every single day. Right. So now we have learned assurance. Okay. In this we had whole life, we had term, we had deferred. The deferred whole life is what we studied. We had pure endowment and we had endowment. These were the main 5 assurances. Then we studied annuity. The main 2 are whole life and temporary. Right. In this we had 3, that is advance, arrears, and continuous. Then we had payable M times for both of them. Payable M times, you can also say deferred, but deferred I do not consider it as a separate annuity. I always say deferred annuity. This is part of temporary, right? Because temporary is whole life minus deferred. Okay, so I don't count it as a separate annuity. Now we'll be using all of these concepts in later on chapters. And also we also studied relationship between everything, right? Relationship between assurances and annuity, relationship between whole life and temporary, whole life and term, term and endowment, endowment and pure endowment, deferred and whole life, everything, right? All the different kinds of relationship. How to convert one from the other, how does the mathematics works, how much probability, discounting, so many different things. So that is why it gets confusing. So that is why I ask you to keep all your formulas at one place so that you can always refer them. Okay. Now in this I will be adding more complications. Up till now I asked you to ignore something that bracket ones, right? Bracket values, I asked you to ignore them for now. Now we will understand what that is. Okay. Now all the tables that we studied, ELT 15 table that we saw for male and female, then AM92 table we saw, in all of them what we were studying was ultimate mortality. Okay. Now we will be studying something called as select mortality. Okay. Now in ultimate mortality, at the beginning of chapter 15, I talked about that mortality or probability that a person might die at a certain point depends on so many different factors, right? The quality of life, the any kind of major diseases that the person might have, the place that the person lives, the job that the person does, right? If the job is very risky, then of course chances of dying becomes higher. If the person works in a mine, of course the probability of dying becomes higher. If the person is just doing a desk job at a company, then it might not be that much. But of course, if the person lives in city like Mumbai, Delhi or Chennai or maybe Kolkata, Bangalore or something like that, where the probability of getting into an accident is higher, then the probability becomes higher. Or you can say the air quality is low, then the probability of death becomes higher because it can cause multiple diseases. Then you might say the stress is high in those cities, then of course the probability becomes higher. So there are so many different factors, okay, that we can divide our mortality tables into. And yes, we do take different mortalities. Okay, now from my experience of taking health insurance and life insurance, I can tell you that in different cities they have different kind of tables. Okay, rather in India they have one table for all the metro cities. So if you live in Mumbai, Delhi, Chennai, Bangalore, Kolkata, all of these major metro cities, they have a separate table for that. And if you live in other cities, maybe Pune, Nagpur, Jaipur or whatever, in those cities they have a different table. Okay, so they will refer to different table, and that is why premium will be different for different places. So they do have different mortality tables for different places according to different because a lot of these factors depend on where you live. Okay, all the risk factors would depend on where you live. And the second factor is income. Now, rather than them saying that, or asking for your income, they know that if you are willing to take a policy of certain amount, then your income might be this much. If you're willing to take a policy of a very high amount, then your income might be higher. Okay, and income range does give you a very good idea about what that quality of life might be. Okay, the risk in terms of what do we say, the pollution, or maybe risk due to the kind of employment or whatever might there be. Okay, so a lot of things you can categorize by that income range and the place where you live. And rather than them asking you what is your income, they will say, okay, if you're buying policy of 50,000 rupees, then okay, I will put you in this range. So rather than telling you, they will say this much is the premium. If you're buying for 50 crores, they will put you in a different category, and they will have different tables for that. Okay, they will not categorize those policies in the same table. But after that, in one table, after all of those selections, when we select one table, in that table we said in ultimate mortality, the only thing that matters is age, right? After we have selected one table, inside that table, the only thing that was varying was age. And according to age, we said we will have different values. So if a person is age 20, we will have a different type of premium and tables and calculations for that. A person who is age 50 will have different calculations for that, right? That is what we were saying, different assurance values, different annuity values and everything. So we said, when we are talking about an ultimate mortality table, the only variable factor there is age. But if we take select mortality, then we have two factors in which those values will be dependent on. First is age, and the second is select period. Let me give you an idea about what that is. Now see, if we are talking about a certain health insurance, okay, one of the reasons why buying an health insurance at a lower age is very profitable for a person, okay, because what happens is, while you take an health insurance, especially as you grow older, what they will do is they will be asking you to do some kind of checkup, some basic checkup, some blood work, some other checkups that tells you that whether a person might have certain kind of diseases. Okay, so that ways they will have multiple categories. A person who is perfectly healthy, does a lot of exercises, has a very good health record, for them the premium will be lower. But then there will be a second category. Okay, person is healthy but it does not have a very healthy lifestyle, so might develop diseases in future. Second category. Third category, the person who has certain diseases right now, especially sugar, BP, these are very common diseases nowadays. After certain age, these diseases are affecting almost everyone. And right now, sugar, BP, these kind of things are affecting even people of age 20, 25, 30. Okay. So what is happening is that is becoming a very big category. So they will say, okay, a person with sugar problem, a person with BP problem, I'll put them in a separate category because they are more likely to accumulate disease or maybe have more expensive treatments in the future. So the premium for those people will be higher. Okay. So for that, what they are doing is they are doing some kind of a checkup. Okay. They will be asking you to do some kind of a checkup. Now that ways, they are relying on the idea that there is some kind of a screening going on in which we can categorize people into different categories. So it's not just age on which we are depending, but also that screening. Okay. So that health checkup. Okay. But if they ask you to do that health checkup every single year, although we should do health checkup very frequently, okay, so that we catch any kind of diseases as early as possible. But if the insurance company asks you to do that health checkup and make sure that and change your premium accordingly, that will be unethical. What does that mean? That let's say a person who has been paying premium for past 10 years now does a health checkup and realizes the person has some kind of a big disease for which there will be a very big expense. And if at that point the company says now your premium goes up, or I would not give you insurance because your expense will be very high, that will be unethical, right? So what the company's policies is, while you take the policy, let's say if you take it at a very early age, they will ask you very basic things, that in your knowledge, do you have these kind of problems? They will say no. We'll say no, I don't know, I don't think I have these kind of problems. Then they will be like, okay. But after a certain age, let's say you take health insurance after age 50. After age 50, they will ask you to do health checkup, because chances that you will develop diseases after age at that age is much higher. So they will ask you to do health checkup if you buy an health insurance policy at a higher age. But if I continue from age 30 and I continue paying the premium every single year, and now I am at age 50, they are not allowed to ask me for any health checkup or any other information from me and change the policy accordingly. They cannot do that. Okay. So that is why it is more advantageous. So let's say at age 30, I am perfectly healthy. That is where I buy that policy and I continue to pay the premium at correct time for till age 50. And now I develop some diseases. They cannot change my policy at this point and say that I will put you in a different category. Okay. So that would be unethical. Okay, that I was talking about health insurance. Same thing happens with life insurance as well. Okay, so in life insurance, again, if there are certain factors, the mortality changes, right? If a person is disabled, if a person is has certain diseases, if lifestyle of a person is not very well or whatever, the mortality accordingly changes. Okay, so while buying the insurance policy, they might have some kind of a screening process, some kind of a health checkup before you buy such a policy. Usually that policy might be very expensive policy. At that time they might be doing it because they might have to pay out a lot of money. So they are like, we should do checkups. For small amount of policies, they don't mind because a lot of people buy that policy and variability there just cancels everything out, and they feel like going through that process of asking everybody to do health checkup might be more expensive for them. So that's a technical stuff, not part of our course. Just trying to say there might be some kind of a screening process that might determine in which category we are in. Okay, or a customer or a policy holder might go in. So we have two factors. We have age, and the second is when did that selection process happen? That screening process, we'll call it as selection process. Okay. So selection period, how long that selection period lasts. Okay. So let's say we did a screening process or a selection process when the policy was bought at age X. As we said, we cannot do again a selection process. We cannot do that screening process again for the sake of changing our policy. So if a person who is age X, we know is healthy, okay, at this point in time we did a general checkup and the person is healthy, does not mean that after age, let's say X plus N, also the person might be healthy. Maybe between these ages the person developed some kind of problem, some kind of diseases. Maybe the person became disabled, maybe accident happened, something, right? It might happen. As we are not allowed to screen again, we cannot take our screening again. What happens is the chances that the person will be again healthy at X plus 1 will be slightly less. And then chances that the person would be healthy at X plus 2 might be a little bit less. After some number of years, this advantage that we had of screening might go away. The advantage of that screening that we did on age X, after some years, we'll say it is as good as we had not done any tests or any screening. Okay. The advantage period at which the time at which the advantage period goes away is called as select period. Okay, so we'll write select period the time after which the advantage of selection goes away. Okay. Now in AM92 we have select, and the select period of AM92 is said to be 2 years. Okay. Select period of AM92 table is 2 years. Okay. So after 2 years, the select and the ultimate tables start giving us the same value. That is what our AM92 table tells us. Okay. So we are doing a small screening or whatever. So for 2 years there is a difference in their mortality, but after that the mortality starts becoming same. So if a person is screened at age X, that is selected at age X, we are saying the mortality between age X and X plus 1 changes. Okay, mortality here changes. And then let's say we are talking about AM92, the mortality effect is for 2 years. So we'll have a different mortality here as well. So mortality changes here as well. But after this we have same mortality as the ultimate table, as if we never screened for anything or we never did a selection. Okay. So when we say mortality selection period is for 2 years, that means the changes stays for the year that we did the selection and 1 more year after selection. Okay. So we show that with X, select X, this bracket X, this would be life aged X selected at age X. if I show select X plus 1, this would be a life aged X plus 1 selected at age X. So right now the person is X plus 1, but the person was selected at age X. Okay, so life aged X selected at age X, we will represent like this. The person is right now at age X, and exactly at that age the person was selected. Here we are saying the person is now at age X plus 1, but the person was selected 1 year ago. That means selected at age X. Similarly, if I say select X plus T, okay, so life aged X plus T selected at age X. Is it clear? That is why in AM92 we have bracketed values as well. Let's look at that when we are talking about L first. See, in ELT 15 male female we do not have any bracketed values because we do not have any selection data here. Okay, but in AM92 when we come up to L, you can see we have L bracket minus X minus 1 plus 1 and LX. So LX was for ultimate mortality where there is no selection. L bracket X is for selection at age X and the person is at age X. L bracket X minus 1 plus 1 is for a person who is still at age X. See, age is, if you see this, put that value X minus 1 plus 1. The person is at age X but selected 1 year ago. Selected at age X minus 1. So if the person was selected 1 year ago, then we will use this. Now why do not we have anything else? Select X plus 2, because for AM92 select X plus 2 will be actually X plus 2, because after 2 years the effect goes away, the advantage goes away. Okay, so AM92 has a select period of 2 years. So we'll be using this. Okay, now this is part of chapter 15. The select and stuff is part of chapter 15. I teach it after chapter 18 just so that we don't get confused. Now let's go to chapter 15 and see and solve a few questions with it. Chapter 15. Okay. If you see, calculate the following probability assuming AM92 mortality applies. Okay, so 15.1. Let's see second part. In second part, what are we saying? We are saying 5P select 79 plus 1. Okay, select 79 plus 1. So in this case, we are saying the person was selected at 79, but right now the person is at age 80. Okay, the person is at age 80. We are talking about going for 5 years. That means going till age 85. And as we said, select X and select X plus 1. These are the only two ages where X plus select will be applicable. After that, from age, selection was done on 79. So after selection 79 and then 80. These are the two places. These are the two ages when selection period will be important. As soon as the person becomes age 81, the advantage of selection goes away. We will be back to the ultimate probabilities or ultimate values. So we'll say this becomes nothing but L, because it's more than 2 years, I will write it as ultimate, so 80 plus 5, 85, upon L select 79 plus 1. Okay, so person age 80 selected 1 year ago. Person age 80 selected 1 year ago. So age 80, so we will go to age 80. Let me just 1 minute. Okay, the person is at age 80 because of 79 plus 1, but selected 1 year ago. That would be this value. So this is the value that we will be taking into account. And of course for ultimate, that is 85, we will be taking the ultimate value. So for 85 we will be taking the ultimate value, that is this, and for 80 we will be taking this value. Select X plus 1. Okay, sorry, first we'll have 85, that is 3, 3, 8, 5, 4, 7, 9, 5. So this is our probability. We get 0.65399997, or we can write 654. For the third, one, that is 2Q select 70. So now the person was selected at age 70. So I will write this as 1 minus 2P select 70. And as we said, after 2 years the select period goes away. So as soon as the person becomes age 72, the selection period is of no use. So this will be 1 minus L72 upon L7 select 70. So as soon as the person becomes age 72, selection period goes away. Selection goes away. So again, for 72 we will be using the ultimate value, that is this ultimate value for 72, but for 70 we will be using the select value. So you can see on this side also we have X value. For 70 we will be selecting the L select value. So let's first write L72. I'll have 1 minus L72. L72 is 7637.6208, and L select 70, would be here, this value. We'll have 7960.9776. This is our probability. Point 0.040618. let's see what we will have for 5 deferred Q select 60. Again, the selection happened at age 60. Selection periods goes from age 60 to 62. As soon as the person becomes age 62, the selection period is of no use. Okay. So when we say we have n deferred Qx, this is nothing but npx q x plus n. This is what we have, right? So here I will have 5p, age is select 60, and then the person is now age 65. Age 65, there is no select period. Okay. So age 65. Q65 is just, now I can use D here. Okay. So I can say this would be L65 upon L select 60, and this I can use D here because D is for 1 year. Okay, D table is given just for 1 year, so D65 by L65. L65 cancels out, and finally I'll have D65 upon L select 60. So D65, I'll go to the next D value. D65 is here, 125.6412, and then L, go back to L select 60. Select value here, I will have L select 60 on this side upon select 60, 9263.1422. You can see at any age, if you see the selected value, okay, selected value, L value you will see is higher than, let's see at the beginning, okay, not here. Let's say at age 65, if you see all the three values, L select 65 will be higher. Okay, in this case it is lower. Actually, the whatever effect might that be, it is making our L select X lower than this if the selection was done 1 year back, and is lower than this, that is if no selection was done, or selection was done at least 2 years before. Okay, so you can see there is the same pattern in every of these values. In this case, whatever selection we are using, it is actually lowering our probability of survival. Okay, it is lowering our probability of survival. So they might be, the selection might be some kind of disease. Okay, so that is why the probability has changed. If the person has that disease, then we'll say comes into this category, that is our selection category. So anyways, this is our answer, 0.013563. Okay, this is how we will solve a select value. Similarly, let's see 5.7, 15.7. The table below is part of a mortality table used by a life insurance company to calculate probabilities for a special type of life insurance policy. So they're saying for a special type of life insurance policy, this is the select. So see, selection is done here, but the selection is running for 3 more years. So total in 4 years. After exactly 4 years, the effect goes away. So therefore, the selection period here seems to be 4 years. Calculate the probability that a policyholder who was accepted for insurance, that means selected. So selected, accepted, it's the same thing. For insurance exactly 2 years ago is now aged exactly 55 will die before age 56 and 57. So what we want here is, we want, first let's think about without selection, what are we talking about? So if we forget about the selection, we are saying a person age 55 will die between age 56 and 57. So I'm saying a person living for 1 year and then dying within 1 year. So you can say P55, Q56. This is what we are talking about. Now we are saying the person was selected 2 years ago, and in 2 years, yes, we do have selection period for more than 2 years. So the person was selected 2 years ago. That means the person was selected at age 53. This becomes P select 53 plus 2, because 2 years have gone. That is why the person is at age 55. And then 1 more year. Okay. So that is third year. Third year, yes, we do have selection. We do not have selection after 4 years. So we'll say Q select 53 plus 3. Right? This is 55. This is 56. So this is what they were asking us. Now how to look that up in the table? See, this table is different from our AM92 table. These all values are not for 51. Okay, these all values are not for 51. This value is for L select 51. This value is for L select 51 plus 1. That means the person is at age 52. Okay, this value I'm talking about. It is L select 51 plus 1. That means the person is at age 52 but selected 1 year ago. Similarly, this value is for L select 50 plus 2. 51 plus 2, that means. Right? So the person is now age 53 but selected 2 years ago. Okay. Now if I want 53 plus 2, if I want 53 plus 2, what I would be looking for? Person selected at age 53 and 2 years have gone. This is the value that I am looking for. And when I am saying select 53 plus 3, I am looking for again 53 plus 3. This is what we will be looking for. But of course, these are QP values, these are L values. So let's convert it into L. Let's convert everything into L. This is 1 year. So this will give me L select 53 plus 3 upon L select 53 plus 2 into, this is Q, that would be D. I will write in terms of D. Later on I will convert it into L. So D select 53 plus 3 upon L select 53 plus 3. L select 53 plus 3 cancels out, and this would be D select 53 plus 3 upon L select 53 plus 2. D can be written dx. Dx is nothing but Lx minus Lx plus 1. This is what our dx is. And when I will add one more value here, that is 53 plus 4. 53 plus 4 will give me actually age 57 directly, because after 4 years our select period goes away. So I will say this is L select 53 plus 3 minus L, directly 57, right? 53 plus 4 upon L select 53 plus 2. Now we can search those values. L select 53 plus 3 would be this. L select 53 plus 2 would be this, and L 57 would be this. So 53 plus 3, 53 plus 3, and 1480 minus 54 is 1470 on 53 plus 2 is 1490. So this value becomes 0.0067114. What about the second part? Second part, they are saying calculate the corresponding probability for an individual of the same age who has been a policy holder for many years. If they are saying policy holder for many years, that just means the select period does not matter now. Okay, select period does not matter. So everything becomes ultimate. If everything becomes ultimate, we are talking about a person age 55 survives for 1 year and dies within the next year, right? This is what originally what we had written before select. This would be, if I write in terms of L, would be D 56 upon L 55. That gives me L 56 minus L 57 upon L 55. I want all of the ultimate values. Here, if I search for ultimate values, all ultimate values are just given here. Okay. So if I want 55, I am looking for X 51. So this is actually L55. This is L56. This is L57. Okay. L55, 56, 57. Let's use that. L 56 1477 minus 1470 upon 1483. So you can see we have substantial difference in probability here. So probability is higher, probability of death is higher for the selection value, whereas probability for ultimate is lower, probability of death here, right? At that particular age. Okay. So we can say that the selection increases the mortality rate. Okay, selection increases the mortality rate, at least for these ages. Let's see what exactly they are asking, commenting. Let's just read that. So for the usual type of policies, that is life insurance and annuity, the policyholder experiences lighter mortality during the select period. Okay, that is just usually what we see. Okay. Here, however, the mortality rate is higher in first than in second. So these policyholder experiences heavier mortality during the select period. That is what we were talking about, right? Mortality rate is higher due to selection or during the selection period. This could occur, for example, if the policy was sold to individuals who had recently had a particular form of medical treatment that increases the mortality rate during the first few years. So they are saying some kind of a medical treatment, some kind of a screening in terms we were talking about, maybe sugar or maybe BP or those kind of things. So mortality rate for those selected people will be higher versus the mortality rate where selection did not occur. Okay. So this selection, we'll be using that concept in annuity and assurances as well, but this is where it is going to be the most complicated. Okay, 15.7, chapter 15 values of the selection period is where we are understanding what selection means, and that is where it is going to be the most complicated. When it comes to the assurances and annuity, it's very simple. When I say A select X, okay, so that just means assurance for a life age X that was selected at age X. Okay, so whole life assurance. So it will just be summation K going from 0 to infinity. We'll have V raised to K plus 1 KP, just we'll have select X here, Q select X plus K. Okay, so let's say we are talking about AM92. So AM92, we know the selection period, okay, or select period is 2 years. Okay, so after 2 years the selection period goes away. So now if I want to write this in terms of series, if I want to write what happens, so when I put K is equals to 0, we'll get just V 0 px we know is 1 and Q select X, then plus we'll have V square, we'll have 1 px that is select X, and then Q select X plus 1, then we'll have V cube 2px, 2p again, X is still select period, so select X, but now when the age becomes X plus 2, when the age becomes X plus 2, our select period goes away. So age becomes X plus 2 and select goes away, so I will be writing X plus 2 here. So only for 2 years the select affected the values, but of course here, because we are saying that we started at age X, that is why it is still having the select value. Okay. This goes on forever. And similarly, ADUX, if I put select here, will be summation K going from 0 to infinity. We'll have V raised to K, KP select X. Again, what we'll say, V, actually 1, when K is 0, 1, and plus V, P select X, plus V square, 2P select X, plus V cube, 3P select X, and so on. Now if I write both of these in terms of L, first of all our KPX, AKP select X, Q select X plus K. Okay, now forget about select here. Okay, if I just forget about select, if I just write KPX and QX plus K, in terms of L will be L x plus k upon Lx, and I will have dx plus k upon Lx plus k. So Lx plus k gets cancelled out and I will have dx plus k upon Lx. So accordingly, my A select x, okay, here will just be V D select x upon L select x plus V square. This will become D select x plus 1 upon L select x plus V cube D. See, after 2 years select period goes away, so I can just write x plus 2 upon L select x. X is still, L will always be L x, L select x. Similarly, V raised to 4, I will have D x plus 3 on L select x, and this goes on forever. So you can see the effect of x is only for 2 years. After 2 years, the effect goes away. But because this denominator was still taking the value from age x, that is why we are always writing it as select x. Similarly, this is what we will have in terms of px, 2px, 3px and so on. So A due select x will be 1 plus V. I will have L select x plus 1 upon L select x plus V square. L, after 2 years select goes away, so Lx plus 2 upon L select x V cube Lx plus 3 upon L select x, and this goes on forever. Now, one of the good things is we don't have to worry too much about these formulas. Of course, these will be very important, especially in Excel, and also for understanding it's very important, but use is very simple. These values are directly given in our table book. If we go to our table book, go to the 4% annuity and assurance table. So annuity and assurance table, you can see on this side we have all select values. A due select x, A select x and 2A select x. Similarly, for endowment tables also, you will have on this side select value, this side ultimate value. So use of select is very easy when it comes up to assurances and annuities. Okay. So of course it should be not even said that next time before Saturday's lecture you should revise everything that we have studied today. It's going to be very important. Rather, every time you should revise everything from chapter 15 to chapter whatever we are studying, because we'll be going much faster, and of course everything that we are studying is going to be used further. Okay. So keep on updating your table book and keep on revising before coming to the lecture. It's going to be very important. Okay. So I've talked about this before, that on this Wednesday, ask me any doubts of chapter 12. Make sure that you ask every doubts. We'll have test. Okay. So let's end our class here and we'll meet on Wednesday. Bye.
Thank you, sir.
Welcome. Okay. Bye.